So let's talk about Microsoft Loop. And right off the bat, I want to be clear. This isn't just some new app. It's a fundamental shift in architecture, a move away from the static documents we've been stuck with for decades. We're talking about a transition from rigid files to living, breathing components. And in this explainer, we are going to deconstruct exactly how it all works under the hood.
All right, here's how we're going to break it all down. We'll kick things off with that big architectural change, then we'll dive deep into the Fluid Framework engine that powers everything. After that, we'll uncover the surprising and kinda hidden storage system, tackle the big dilemma facing developers with the API, see how automation and integration actually hook in, and finally wrap up with how you can realistically secure and govern this whole new world.
Okay, first things first. To really get what makes Loop so different, we have to contrast the old way of working with this new paradigm. And trust me, it is a much bigger leap than you might think. So, what's the crucial point here? We are moving from static files, these rigid boxes like a Word doc or an Excel sheet, to what are called fluid components. These are tiny, portable units of information. They can live in a Teams chat, in an email, and in the Loop app, all at the exact same time. And they're all powered by a totally different sync model that pretty much kills that annoying lag you get in co-authoring.
So, what's the magic that makes all of this possible? Well, that brings us to the core technology, the Fluid Framework. This is the client-centric engine, and that client-centric part is key. That makes the whole experience faster and way more resilient.
Now, this is where things get really fascinating, because it completely flips the script on what a server normally does. With Fluid, the server isn't the brain anymore. It's not doing all the heavy lifting. Think of it more like an air traffic controller. It just takes in all the incoming edits, stamps them with a sequence number to keep them in order, and then broadcasts them back out. All the real work, that's happening on your device.
And this slide, right here, this shows you the secret sauce behind Loop's incredible responsiveness. In the old world, you type something, your computer sends it to the server thinks about it, merges it, and then sends the result back to you. That round trip is latency. In the Fluid model, you type and your screen updates instantly. All the complicated work of merging your changes with everyone else's happens quietly in the background.
And the result of all that client-side smarts, it's something called optimistic updates. The system is optimistic that your change is going to be fine, so it shows it to you immediately. You don't have to wait for the server's permission. That's what gives you that seamless, truly real-time feeling, even if you're on a choppy network. Now, developers don't have to build all this complex merge logic from the ground up, which is great. Instead, they use these pre-built components called distributed data structures, or DDSs. Just think of them as smart building blocks that already know how to resolve conflicts. For example, a shared string knows how to merge text edits from two people at once, while a shared tree knows how to reorder items in a checklist without causing chaos.
Okay, this client-first model is awesome for speed. But wait a minute, it brings up a huge question, right? If a Loop component has been edited 1,000,000 times over a year, does a new person joining the team have to download and process every single one of those million edits just to see what's going on?
Nope. And the way Fluid solves this is actually super clever. It's a process called summarization. Every so often, one of the active clients in the session gets elected to be the summarizer. It takes a snapshot of the component's current state and saves it. So when you join, you just download that latest snapshot plus the handful of changes made since. This keeps load times lightning fast, no matter how old the component is.
All right, let's talk about where all this data actually lives. And here's another twist. It's not stored in a normal SharePoint site that you can just browse to. Loop uses a headless storage layer called SharePoint Embedded. Think of it as a pure back-end system with no user interface. And you have to pay attention to this part, especially if you're in IT or governance. The physical location of a Loop component is, well, it's fragmented. If you create it in the Loop app itself, it lives in one of those hidden SharePoint embedded containers. But, and this is a big but, if you create it on the fly in a Teams chat or an Outlook email, it's just a regular Loop file sitting in your personal OneDrive. Where it's born determines where it lives forever.
And this is a really big deal, because that .loop file itself, it's basically a black box. You can't just open it in Notepad and see the text inside. It's a compressed blob of data that only makes sense to the Fluid framework. This creates a massive challenge for your standard backup, migration, and e-discovery tools that expect to be able to read file content.
So you're a developer. You see all this cool tech, and you're thinking, awesome, how can I build on this? Well, the story gets a little complicated here. There's a pretty stark divide between what you can do and what is completely off-limits. Okay, if you're a developer, this is the one thing you absolutely need to burn into your brain: As of today, there is no public API that lets you programmatically read the text inside a Loop component or, say, add a new row to a table. It just doesn't exist. And it makes sense, right? The server doesn't know the final state of the content. It only knows the stream of edits.
So to put it simply, the API lets you manage the box that the Loop component lives in. You can list workspaces, create new ones, manage who has access. All that container-level stuff is fine. But you are completely 100% locked out from touching the actual content inside that box.
So, how are you supposed to get external data into Loop? Well, the official workaround is kind of wild. You don't touch Loop at all. Instead, you build a bot that serves up something called an adaptive card that just pretends to be a Loop component. All the interactions and updates are handled by your bot in the background, which keeps refreshing the card for everyone, creating this illusion of a live, real-time component. So you can see how this big API limitation has a huge domino effect, right? It forces a major pivot in the whole strategy for automation and how Loop connects to outside services like Jira or GitHub.
And if you've ever pulled your hair out because the old Jira integration in Loop was buggy or just stopped working, well, there's a reason for that. That entire model of building direct, hard-coded connectors is being thrown out. It's just too brittle and breaks every time a third party changes their API.
The new modern way of doing this is way smarter and more flexible. You just use a standard Loop table. Then you set up a simple rule on that table, like when a new row is added. That rule then kicks off a Power Automate flow, and Power Automate becomes the bridge that does all the work of talking to Jira or Salesforce or whatever other system you need.
And even for the integrations that are built in, like the one for GitHub, there are some pretty tight guardrails. For example, there's a hard limit of 100 issues you can pull in. This isn't just an arbitrary number. It's there to protect the performance of the component, because remember, all that data has to be loaded into every single user's memory.
Okay, last but definitely not least, let's talk about control. If you're an IT admin, you're probably looking at all this and wondering, how on earth do I manage and secure this fragmented new type of content?
So at the end of the day, what's the big takeaway? It's all about aligning your strategy with how the platform actually works, not how you wish it worked. For developers, that means stop waiting for a content API and start embracing adaptive cards. For architects, it means treat .loop files like any other new file type and apply your existing governance and DLP policies to them. And for integration teams, it's time to rebuild those old connectors using the power and flexibility of Power Automate.
And all of this really leaves us with a massive final thought to chew on. If our information is no longer trapped inside individual documents, if it can live in multiple places at once as a single synchronized entity, how does that fundamentally change our very definition of what a file even is? And what does that mean for the future of how we work?